Okay, so we are going to start with measuring dispersion. This is also very important, but we start with something critical. We only measure for dispersion if we have a ratio or interval scale, right? Like if we have a scale variable like height, like income, like you remember, right? Like the scale variables, ratio or interval, temperature, all of the altitude, all of these things. So, and in here we have mainly two things. First, the range, because the range tells you how wide or how large your data is. So for example, if I want to measure the age of students in high school, probably this is kind of very simplistic assumption, but their age should be around 15 and 18. Well, I think I'm using the Mexican high school age because it lasts 3 years and you usually start when you are 15 and you will probably end up at 18. So that will be the range, the minimum and the maximum in your sample. So this is a useful statistic because it tells you how wide dispersed your data is. Imagine that you want to calculate the average age. Oh, sorry, you want to show me or your sample is about the age of every person in Sweden. Then it will be much bigger or much larger, right? Because it should start in 0 with the babies. And it will end up with, I don't know, like 108 or something. I don't know who is the oldest person in Sweden, but it will be much larger than if it is only about high school. Probably you might have like someone who is doing high school, I don't know, like at the age of 28. I don't know, like someone who is studying late. So maybe you have someone who is a bit far from what we thought it would be. So this is actually what we identify as an outlier, because if most of the population, sorry, most of your sample is in here, like let's say 99% of the people are in between 15 and 18, and you have one person at 28, the range will officially move from 15 to 28 because the range is calculated by this subtraction, the maximum observation minus the minimum. So again, similar to what we learned in here with this, similar to that, we can also make our own judgment, and we can say that this is an outlier because the 99% of the people lying here and we only have one there, and we can cancel this observation. We can exclude that one from the sample, and then we will have a range of only 3, right? Because it's 18 minus 3, not minus 15, sorry. So this is one possibility that you have this. But the other important thing is the standard deviation. The standard deviation is a calculation that is also very powerful, because let's go to this, like the age. Or no, let me think about a better example for the standard deviation, because in the standard deviation, what we want to show is if in your observation, you have a mean in here, like you have all of your observation and you have this mean, the standard deviation will tell you how far everything is from the mean. Like maybe grades is a good example. Maybe grades is a nice example. So let's assume that in your grades, you can have F as failing or A, the best grade possible, right? And maybe the average is C, right? So C is the average. So the standard deviation will tell me how close my sample is from the mean, C. So to explain you the standard deviation, let me explain you a few things that are behind that. We have one thing that is called the error. The error is when you have one observation that doesn't fit the mean. For example, if you got a C in the course, like this, you are this observation, you got C, your error is 0 because you are in the mean. So you don't have error, you are 0, okay? But if you get a B, then you have error because you don't fall in the mean. So your error is, and here is an interesting thing, because how do we how do we calculate these things, right? Like the numbers. So maybe let's assume this is 100%, this is 80, and this is 60, right? Or 59. It is easier because then if I use the letters, I am not, remember, ratio variable. So the letters wouldn't work. It's better if we use the numbers. So 100%, 80%, 59, and maybe you got 90, right? You got a B. So if you got 90, that means that your error is 10, okay? 10 is your error. If you have more people around here, you have more and more error. If you add up, if you make a huge sum of all of the errors, if you first square your error, so 10 times 10, and you sum all of the errors, that will give you the variance. So that is also an important thing, the variance. The variance is only squaring all of your errors times the same thing, squaring all of the errors, and that is the variance. So if you have a huge variance, that means that your observations are far from the mean. You have a lot of observations far from the mean. Okay, I hope that you are understanding it a little bit. Maybe in the actual lecture we can do it with the marker and more examples. So let's assume that maybe in another group, everyone got a C. Everyone got 80%, everyone. So then the error is 0, and then 0 times 0, and you add up all the zeros, that means the variance is 0, right? If the variance is 0, that means that it is constant, right? Like it doesn't change, it doesn't change. So if the variance is 0, it is not that relevant, it's just a constant. We can't do a lot, we can't analyze a lot if the variance is 0. So we like when we have some variance, like not a lot of variance, because if it is so random that you have everyone everywhere, then it's very difficult to make an analysis. So we like a point in between. When you don't have variance 0, that everything falls in the same thing, we like this. When we have people all over different ranges, that's what we like when we are analyzing things. And finally, the standard deviation is only the square root of this number, okay? So if the variance is 100, then the standard deviation is 10. We are going to talk a little bit more about standard deviation later, but in conclusion, the standard deviation reflects how the observations move from the mean, and the larger the standard deviation, the further away they are from the mean, right? So I hope that you get it. We have formulas for all of this, but it's not the objective of the course that you're not doing a bachelor in statistics. It's more that you understand the logic. And then the software helps a lot, so you don't have to do it by hand. But it's very important that you understand what is the standard deviation and where it comes from. So the standard deviation comes from the error. The error is how far my observation is from the mean. If you square that number, that error, and you sum or you add up all the errors from all the observations, that is the variance. And if you square root that number, you have the standard deviation. So not very difficult. That's where it comes from. And how do you interpret that is the larger the standard deviation, the further away they are from the mean. So I hope that it made sense. If not, rewatch the video. If not, come to a lecture. If not, wait until quantitative. But here we have a way to show dispersion. This is how do you report dispersion. So usually you also have a table. You have valid and missing as before, as in here. And then you report the standard error. The standard error is also another thing, but it's almost the same as a standard. It shows the same thing as standard. So you have variance, you have standard deviation. These are the numbers. So it's quite large, right? Like it's quite large. It means that the observations are far from the mean. Then you have the range. This is the maximum minus the minimum. Then you also show the minimum. So I think the minimum is 54 pounds in return, and the maximum is almost 5 billion. This is 54,000, I think. And you can even build what we call percentiles. Percentiles, we're going to talk about that later. It's not that relevant, I think, for you, for the objective of what we want to achieve, but it is another way to build these things. You remember the intervals, because here we have 5 intervals that you randomly chose, but here we have 4 intervals, or 3 in this case. Like you divide the sample in 3, and you find like where is the point where the 25% of the observations stop. So from 25 and below, we have 52,000. At 50% is 158, and at 70% it is 742. If we go back to the histogram, it will be like dividing it in, it looks horrible, but it would be like dividing it in like these points, like something like this, right? Like you divide your observations in, it looks horrible, but the 25% of them, the smallest or the less 25% should be around here. I think it was 50 something. 50% of the observation should be around here, and 75% of the observations should be around here. It's another useful thing, but I think it's not that relevant right now. It's just only to show 25% of the less, where does it stop? 50% of the less, of the smallest observations, where do they stop? Here, and 75% where do they stop? But we can dig on this later. So I think that dispersion is also important. It was a long video because of the standard deviation, but I hope that you understand what standard deviation is.